Hello and welcome to your ninth Algebra 2 and Algebra Trigonometry class. Now we're still using the same video for both classes, but at some point during this week, the Trigonometry class is going to have an entirely different content from this one. But for the time being, let's get started. Today's topic is direct variation and also graphing equations of lines. Now, graphing equations of lines is a topic that you see in Algebra 1, just like direct variation, so we're not really going to go in depth into them. But I do think it's pertinent that we review them. Also, along with this video, I will upload some exercises, or I will send you some exercises that are not in your math sharpener, so that way we can start working. That being said, let's do this real quick. Now, so far we've been talking about linear functions. So the formula that we're going to be using to graph our functions is y equals mx plus b, where m is our slope and b is our y-intercept, right? Now, when we look at this equation, the first step, or the first thing that we want to look at, is to make sure that the equation is solved for y. If it isn't solved for y, that means you have to. Or if it's solved for y, but it's not arranged in y equals mx plus b, then you have to rearrange it. So in this case, it's not solved for y, so the first thing we're going to do is do that. And if I want to solve it for y by, in this case, subtracting 3 on both sides, and that would be y equals negative 2x minus 3. Now, I look at my equation and I realize that it is in fact in the form of y equals mx plus b, so now I don't really need to do anything else other than identify my slope, identify my y-intercept, and graph. So my slope is actually negative 2, and my y-intercept is negative 3. Now, what the y-intercept means is that whenever I have a y-intercept, x equals 0. Or in other words, what the y-intercept means is that point in which the line actually touches or crosses the y-axis. In this case, y is negative 3, so that means that x equals 0, which means that I have an ordered pair of 0 and negative 3. Now, to graph that, the first thing I'm going to do is graph this ordered pair. 0 and negative 3. 1, 2, and 3, which is down here. Now, in order for me to complete the graph, I actually have to look at my slope. My slope is negative 2. Okay? Now, remember that whenever you calculate slope, the slope is calculated by dividing y over x. So, technically, the slope is... and I'm going to do that right down here. Slope is actually, slope is actually negative 2 over 1, because the slope is always calculated by dividing y over x. So what that means is that from this point, from the 0 and negative 3, I'm actually going to move down 2 spaces, 1 and 2, and 1 space to the right. And that's more or less where my ordered pair would be, and then I'm going to graph, right? I'm going to connect, the points and graph my function, and that's how I graph that equation, okay? So I'm going to go ahead and let you look at it real quick, just making sure that everything is working properly, and I'm going to go ahead and erase it and do the next one. So I'm going to erase this example. You can pause and rewind the video. Now, I will be sending you the practice problems. They are not in your math sharpener. I'll actually be either emailing them to you or texting them to you, so you guys can... The other problem that we need to graph is y equals 5 minus x. Now, the first step is to make sure that it's solved for y. In this case, it is, but does it resemble mx plus b where the slope is in front of the y-intercept? It does not. So what you're going to do is rearrange it. And you're going to rewrite it as y equals negative x plus 5. Now, negative x because I include the minus sign here, and plus 5 because 5 is positive. Next is to identify who's my slope and who's my y-intercept. My slope is actually negative 1, and my y-intercept is 5. Now, remember that the y-intercept means the point in which the line crosses the y-axis. In this case, it's positive 5, and x equals 0, so in reality, that's the ordered pair 0 and 5. Okay, so what you're going to do next is graph 0 and 5. 0 is my origin. 1, 2, 3, 4, 5. Now, after that, I need to find my second point, and I do that by looking at my slope. So remember that the slope is always y over x, so negative 1 is the same thing as saying negative 1 over 1. And what that's going to do is I'm going to actually go down 1 unit and then move right another unit, because y is negative, so that means 1 unit down, and right 1 unit because the other one is positive. So 1 and another one to the right, and this is more or less where my other point would be. I connect the dots, and I graph my line, and that's how I graph this equation, okay? So again, just make sure that it's solved for y. If it isn't solved for y, solve it. If it's solved for y, but it does not resemble mx plus b, rearrange it, and then graph. Now we're going to look at our other example, which is direct variation. Now, ladies and gentlemen, once again, the practice problems for this topic is not in your math sharpener. I am going to text them to you or email them to you so you guys can start working on that. Now, direct variation. Now, when we talk about linear functions, they vary directly, which means that one causes the other one to rise, or they vary indirectly, which means one causes the other one to decline. That's what we call direct variation, or dependent and independent variable, where one variable is dependent on the other, okay? Now, for direct variation, there is a formula, which is y equals ax, where a is what is considered the constant of variation. And this is used a lot in studies in science and in engineering and even in marketing, in some cases, to study the behavior of certain functions. Now, it says the variables x and y vary directly, and y equals 76, x equals negative 8. Then it says write an equation that relates x and y, then find y when x equals negative 6. So it's actually a two-part problem. And it sounds like a mouthful, but it's really easy. And what you're going to do first is find the constant of variation. Now, the way I do that is by plugging in the values that were given to me. So y is going to be 76, a is what I'm looking for, and x is negative 8. So I actually have 76 equals a times negative 8. What I'm going to do is divide by negative 8. So I divide by negative 8. This is going to cancel out. And 76 divided by 8 is negative 9.5. So a equals 9.5. Or negative 9.5. I have my constant of variation. Now the formula would be y equals negative 9.5 x. So I have my direct variation formula. Now I want to find out what is the value of y when x equals negative 6. So step 2 is just to take this formula. Oh, this is step 1, guys, and step 2 is simply y equals negative 9.5, but instead of saying x, negative 9.5 times 6, okay, so you multiply negative 9.5 times 6, this is 30, carry the 3, 6 times 9 is 54, 57, and y equals negative 57. So that's it. That's my direct variation formula. That's how I graph linear equations. I will text you or email you both practice problems. So this is your favorite math teacher. Stay safe, and I'll see you guys soon. Bye.